Today we're going to work on applying all of our exponential rules to real-world situations. So while this paper doesn't have a place for it explicitly stated, let's put your name at the top of your paper so what is yours stays yours. Okay, so we're going to take situations and just be forewarned that you're going to have to use your exponential rules. Why don't we write out our exponential rules very quickly over here to the right side of your paper. So let's see. A to the m times a to the n. What did we do with the m and the n? Do you remember? Good. Let's add them together. A to the m divided by a to the n. What did we do with those exponents? Right, we subtracted them. A to the m minus n. What about ogres have onion? Ogres are like onions. They have layers. Good. That's where we multiply the m and the n. That's our power to a power rule. What's our negative exponent reciprocal rule? A to the negative m is equal to 1 over a to the m. Good. We said any number in the whole wide world to the 0 power. This one's our favorite. Yeah, that's 1. And then we had one more rule that we learned last time, where we can shift gears out of exponential form into radical form, and we just have to put things where they go. So we said the denominator of the fraction, that's your root, and the numerator of the fraction, this is your grand exponent. Okay, there's all of our rules. Let's actually start on number 2. You will get to do number 1 on your own. I thought you would like it if we did number 2. So a pizza shop makes large pizzas with a target diameter of 16 inches. That's a good sized pizza. A pizza is acceptable. So I guess they're making these by hand, like you see in the movies where they throw the dough up in the air. So the diameter is acceptable if it is within this range of 3 times 2 to the negative 2 inches of the target diameter. We are going to let D represent the diameter of the pizza, and we're going to write an inequality for the range of an acceptable large pizza with the diameter in inches. So we have to write an inequality of the range. That's what we're doing. And we know that the diameter that is desired is 16 inches. And there's an acceptable adjustment. All right, so let's look. So the pizza can be a little bit too big, but not too much, and a little bit too small, but not too much. So let's see how this goes. We have an acceptable width. So if it's going to be a little bit too small versus a little bit too big, we have to think about how would you make something small? Because I know that they want my perfect diameter of 16. The small is always less than the perfect thing. The big is always slightly larger than the perfect thing. And they would like it to be 16, but you know, life happens. These are being thrown by hand in the air. So if it's small, do you make it shrink or grow? Shrink. Good. So if you're going to make it shrink, do you add or do you subtract? Good. You subtract. So this will be my perfect 16 minus that acceptable adjustment. So if it's too big, we have to make it grow. And if it's growing, then we would add on to the perfect 16. So here's the perfect 16, and we are going to add on this acceptable adjustment. All right. So that's the range. I mean, that's it. What does it mean? Who talks like that? Who thinks like that? I do not talk like that. I do not think like that. So in your calculator, we can determine what this 3 times 2 to the negative 2 means. We can determine it by hand. So let's look at it real quick. Let's find out what we're actually subtracting and adding to our 16s. 3 times 2 to the negative 2. All right, 2 to the negative 2. What does the negative mean? Flip over this base of 2. All right, I did that. What is 2 squared? 4. This is 1/4. Okay. What is 3 times 1/4? Yeah, it's 3/4. And then if I were to write 3/4 as a decimal, what's 3/4 worth? Yeah, 75 cents. So this is our acceptable amount of adjustment. All right, so let's put it to work. Now that we know what it means, let's put it to work. So this is really 16 minus 0.75, which is equal to what? Put it in your calculator or your brain. They both work. Did you get 15.25? Good. So the smallest that diameter can be is 15.25 inches. We hope for 16. And the largest it can be 16 plus 0.75, which is 16.75 inches. This is the acceptable range of the diameter of our pizza. They really check those things. You don't want to waste money. You don't want to give customers too much food. They didn't pay for it. You don't want to give them too little food because they did pay for it, and that would be theft. So, yeah, there you go. Isn't that crazy? All right, you get to do problem number 1. Let's go do problem number 3. Problem number 3, we need to find the area of each figure. Okay. So How do you find the area of a rectangle? Area equals length times width. Yeah, you remember that. So the length and the width. We usually put the smaller number of terms at the front. That's fine. It really doesn't matter which one you make the length and which one you make the width, as long as both of them are accounted for. Okay, let's go distribute, combine like terms if possible. Big 4 times big 3, big 12. X squared times x squared. Do you remember what to do? That's right, add the exponents. This list is going to be super helpful for you today. So squared plus squared makes to the 4th. Great. Positive times a positive is a positive. Big 4 times big 2, big 8. X squared times x to the what power is this? Does it have an exponent? Sure it does. If there's nothing there, it's a 1. Exponent of 2, exponent of 1. What did we say we were going to do? We did it here. Add them. That's right. 2 plus 1 makes x to the 3rd. Okay, in order to combine my terms together to make 20, those x's have to have the exact same exponent. Do they? No. This is it. You're done. Congratulations. Ta-da! Alrighty. Let's go look at problem number 5. What's the formula to find the area of a triangle? Do you remember? Area equals 1/2 base times height. All right, let's go do it. So 1/2. Again, it does not matter what order you multiply in, as long as everything is accounted for as you are multiplying. So here is my 5b. Make sure your handwriting knows that's a b, not a 6. And then here is my base of 2b squared minus 4. All right. So let's just let this 1/2 hang out for a minute, and we'll deal with him later. For right now, let's distribute the 5b through this parentheses quantity. Use your parentheses to tell us that we have to still deal with this 1/2 later. Big 5 times big 2, big 10. B times b squared is b to the 3rd power. Good job. A positive times a negative is a negative. Nice. Big 5 times big 4, 20. And there's a b here. It just doesn't have another variable to multiply with, so we'll just bring him along for the ride. All right, now sounds like a good time to deal with this 1/2. So this 1/2 is a coefficient. It is only going to affect the coefficients. So let's distribute it. What is 1/2 of 10? Yeah, 5. b cubed. A positive times a negative, it's a negative. What is 1/2 of 20? Yeah, it's 10. b. All right, it's time for the $1,000,000 question. Can we combine like terms to get -5? These b's, that's fun to say a lot. These b's, do they have the exact same exponent? No, not at all. This has an exponent of 3. This has an exponent of 1. This is done. That's it. Isn't that great? All right, you get to do number 4 and number 6. Pause the video, and if you need some help, come and talk to me. Let's do number 7 together. The volume of a circular cone can be determined from this formula. 1/3 times pi, 3.14, times the radius squared times the height. All right. Hey, I know. Let's box that because I'm thinking it's going to be super helpful. Where r is the radius of the base and h is the height of the cone. So we need to find the volume of the cone shown at the right. There it is. So here it does matter which is the radius, which is the height. It doesn't matter the order that you multiply them once you've put them into their equation. The reason this is an issue is because this radius is squared. The height is not. So I need to make sure I know which term to square. So this 15, this is the height. It went straight up and down, height. And remember, from the center to the edge of your circle, this is the radius. Great. Now we can put things into our equation and go solve. Let's write our quantities here in our space that is provided. H equals 15 and R equals 4x cubed. All right, let's go plug things into the formula. The volume is equal to 1/3. This really should have parentheses around it just so we know why we have all these numbers here. Times 3.14 times my radius, 4x cubed, my radius squared, times my height of 15. Yikes, that's a lot of numbers. All right. Well, you've got a calculator, and it's really going to help you. So let's go find out what all of our true numbers are that are going to help us in the calculator. We have to distribute the squared through this quantity. Ogres are like onions, they have layers. The volume is equal to 1/3 times 3.14. I have 4 squared. I have x cubed squared. Remember, we multiply those exponents together, times 15. Okay, calculator, help us out. So let's start on a new document. And type all of this in. We've got parentheses. Let's use our parentheses. They'll just help keep us clear and straight. Control divide, so I can put in this 1/3. 1/3. Arrow to the right. Close your parentheses. New parentheses. 3.14. Close your parentheses, open your parentheses, 4 squared. Close your parentheses. Let's skip the x to the 3 squared right now. Let's skip that and just put in the 15. Because we just want to do all of our hard numbers, our concrete numbers together, and then we'll deal with the variable. Okay, did you get 251.2? I hope so. So V equals 251.2, and then we'll deal with this. X to the 6th power. Done. That's it. So the part that I think most people are scared of, the exponents, ended up being really simple. It was the big concrete numbers that people say they like that was some work. But thanks to the happiness of your calculator, that wasn't too bad. You go do number 8 and then come and talk to me if you need a little help.